So if we consider an overview of skin, and in a minute I'll do a diagram for you, what you can see on this slide is that the skin has three main components. We have the epidermis, the dermis, and what has been known as the hypodermis, but which dermatologists prefer to call the subcutaneous layer. Hypodermis obviously relates to hypodermic needle. It's where injections that were made that are made into the skin go. This is now known as subcutaneous injection, and this is the fat layer, the adipose layer, that is beneath the skin. So strictly, skin, the largest organ in the body, consists of the two main layers, the epidermis and the dermis. So we'll do a summary diagram of it at the start. And basically, okay, so what we have here, this is the sort of summary outline, and I'll just add some more stuff on in a minute, is that in the upper part of the skin, so this region here is the epidermis, which is effectively the epithelium of the skin. And this is a stratified, squamous, keratinized epithelium. And we'll look at the details of the epidermis in a moment. Beneath it, we have the dermis, running all the way down here. The dermis is full of lots of collagen fibers. So the dermis is a connective tissue which is full of collagen. There. And we'll talk again about the structure of the dermis in the next lecture. The features that you should note here are that extending down from the epidermis into the dermis, and these are extensions of the epithelium, so they're epithelial derivatives, are two key structures. One of these is a hair follicle here. If we were going to draw, we could draw hair in it if we wanted, but the hair sits in there like that. So there is a hair follicle, and associated with the hair follicle, on the side of the hair follicle, is the sebaceous gland. And the sebaceous gland produces sebum, and it is infection of the sebaceous glands that leads to acne. And we'll talk about that. So this gland, lots of large cells in it. Like I say, we'll do the details of all of these things later on. The other major structure, and the glandular element of it, the secretory component, is down here. This is the sweat gland. And the cells which do the secretion of sweat, and we've looked at that secretory mechanism in the past. We've looked at it in the context of cystic fibrosis. We talked about how secretion takes place in sweat glands. We've also talked about how reabsorption of chloride and sodium takes place in the duct of the sweat gland. So this is the duct, which runs all the way up through the dermis, runs through the epidermis, and opens onto the surface. Both hair follicles and sweat glands are derived from, as I've said, from the epithelium, and their location is important. And we'll talk about that later when we talk about skin regeneration and skin grafting. Because these are epithelial, they can actually give rise to the cells of the epidermis. And so if you damage the surface of your skin and lose this epithelial component, then it is cells from the sweat glands or the hair follicles which start to divide, proliferate, and recover the surface. And so the presence of these components deep in the dermis is important when skin is in its regenerative phase. So we have the sweat gland, the secretory bits here, and then beneath the skin, down here, we would have the subcutaneous adipose layer fat. The hypodermis. Okay. So, if we go back to the PC image, the other things that you'll see, the key features that are referred to here in this overview, the epidermis is a stratified squamous keratinized epithelium, and as we've shown in the drawing, extends into the dermis as those glands, also as nails, are derived from epidermis. The dermis itself is this dense, irregular connective tissue, lots of bundles of collagen fibers present in the dermis. It contains an extensive vascular plexus, talk about blood supply a little later on, and is linked to the epidermis through the basal lamina. The epidermis is an epithelium and therefore secretes its own basal lamina, and the collagen fibers that are present in the dermis attach to that basal lamina from beneath, and that helps to anchor the epidermis onto the dermis. It's obviously important that your epidermis is held tight, particularly in areas like the tips of the fingers where you don't want your skin sort of moving sideways and slipping off as you try to grasp things. And so the anchorage between epidermis and dermis is quite important. And it's done in a couple of ways. Go back to this visualizer image. Then you'll note here that there are a number of little, I drew it wavy, these are protrusions of the dermis into the epidermis. These are known as the dermal papillae. That one of them is a dermal papilla. So these little, like pegs, imagine them as little pegs of the dermis sticking up into the epidermis. Rather like little pegs on top of a Lego brick that stick up into the brick above. And so these are holding and help to hold the dermis onto the epidermis. So there's a mechanical holding there. And you won't see them in many regions of skin. But if you look at the tips of your fingers, then the lines that you will recognize as fingerprints are actually reflections of these invaginations of the dermis into the epidermis. And so in certain areas, on the soles of your feet and on your tips of your fingers, these are extremely deep and form actual ridges and lines on the surface of the skin. So the dermal papillae here help to hold that in. And then we have the sort of attachment of collagen fibers from beneath, sticking into the basal lamina beneath that. helping to anchor as well. So we've got a number of mechanisms for holding the epidermis into place on the dermis.